Hello, everyone. Welcome to the Google Marketing Platform Academy on the 25th of June of this year, where today we're going to talk about predictive lifetime value. We're going to show you some cool things in BigQuery as well around the topic of lifetime value. To introduce myself, my name is Vincent. I'm a platforms account manager, mostly working on the Benelux market. You might have seen me in one of the previous videos of the Google Marketing Platform Academy. And today with me is Wojciech, if you want to introduce yourself.
Yeah, sure. Hi, everyone. My name is Wojtek Hejna. I'm a customer solutions engineer. I'm based here in London, and I'm also working with UK clients.
Cool. Before we get started today, I wanted to share that the Google Marketing Platform Academy is something we do more continuously about a lot of different topics, where we have the weekly live on-air sessions, like one of them today. But on top of that, we also have the bi-weekly newsletter. So I highly recommend to sign up for that one today to keep posted on everything that's happening in the Google Marketing Platform. But today we're talking about, Wojciech, if you can show the agenda.
Yeah, sure. So today we're going to talk about 4 different topics, starting with the first-party data, the power of them, how they can be useful for your marketing strategy. Then we will move on to the lifetime value, how we can calculate it, how can be also, what tools can we use to make it effective. And then we'll take a look on the more complex use cases or how we can use the lifetime value in practice. And finally, we will have a live demo with the propensity modeling, some cool predictive capabilities of BigQuery ML.
I'm really curious. So let's get started off the power of first-party data. But if you think about the power of first-party data, I think first we need a definition of what do we mean with first-party data, because I think you can have different perspectives. And the way I would say my perspective or Google's perspective on first-party data is data that you own yourself as an individual or as a company or as an enterprise. And especially if you take the business perspective there, it's usually the information that you collect about your customers. And if you think about the information you collect about your customers, you maybe have like customer relationship management systems or CRM. You might have a loyalty card or a subscription program where you do data. Maybe during the checkout, people say what they've bought and maybe give some identifiers. But you can even think about the online perspective, where you think about social media channels where people subscribe or give you particular likes. Think about people signing into your platform or buying particular e-commerce products. Meaning first-party data has a very broad scope. And I think that today that the thing we want to land here is saying you can use all of that in various ways to say, I use that to make an advanced model, but also activate the data for your marketing capabilities. But then the definition of first-party data for us is the data that you own, I would say. If you go to the next slide. So if you think about first-party data is everything that you own, that means that every time you have an interaction with a customer, you have an opportunity to collect data from them, if, of course, you have the right consent, etc. So if you think about a coffee store, there could be the moment that someone buys a coffee. If you think about someone looking up your store, it could be that they're searching on Google Maps to find the store location. It could also be that they're surfing your website and they want to purchase something. But every single customer interaction provides an opportunity for you to capture a piece of data to learn a little bit more about your customers. And then thereafter, we can model it to see if we can make use of the data that we've collected. Go to the next slide. If we just think about first-party data and we look at the subset of that, where we only say, let's only look at website data, then studies suggest that companies that use website data to kind of drive their visits have a 44% less cost per acquisition and a 30% higher conversion rate. So if you think about first-party data, which is a very big topic, if we only use the website data, we already drive very significant results. And I think that's the goal we're trying to achieve, where we say, all right, try to move as much as your first-party data, because we already know that if you use a subset, you have tremendous results. If you go to the next slide. So what I can try to say is this example shows you the impact, but the website visit is not all the first-party data that you can use. So it's much bigger than that, meaning the ballpark numbers I just gave about the 40% less CPA or the increase in conversion rates, we can even do better than that. And that's what we kind of mean. So we go to the next slide. If you think about measurable signals, so we just mentioned the example of looking on Google Maps, or we mentioned the example of visiting your website or buying a coffee. If you think about different buckets, what you can think about is, first of all, the big one, which we already explained, is site behavior. What are they doing? How long do they spend on the site? How many pages do they look at? I think for a lot of online retailers, it's very interesting to include e-commerce data. What products are they buying? Do they buy a group of products, or do they buy them one by one? Maybe on top of that, next to the e-commerce, you maybe sell something offline, right? Have some offline signals. Think about retail stores where things are being sold, or think about call centers where certain acquisitions are being done that's stored in CRM. That's also a very big bucket. There's also a moment, if you think about the funnel approach, from entering your website to checkout. Some people are still stuck in the shopping cart, so they're interested to buy it but haven't bought it yet. It's a very interesting signal that you can use. And finally, we're talking about a marketing perspective, mostly with Google Marketing Platform. Why is we're driving certain channels to make sure people come to your platform. But I think it will be very interesting to understand that maybe a search advertisement drives completely different behavior than a display advertisement. Meaning, think about the insights that you have, and I think these are 5 very concrete buckets of signals that we're going to start using. Go to the next slide. And why do you think it's important? Like, don't just trust me by my words, but actually Google and BCG did a study together where we asked a lot of different companies about, all right, how important do you think first-party data is in digital marketing? And actually 9 out of 10 people, 90% of people or companies said, yes, this is important. However, the majority is not using it. Only 1 out of 3 of who's saying it's important is actually collecting and integrating data across channels, which is the only step of getting the data out of the systems and make some insights out of it. And then after that, only 1%, meaning 1 out of 90 that finds it important, also delivers the cross-channel and customer experience on top of that. Meaning we all know it's important, or most of us believe it's important, but we have a lot of opportunity to tap into to really use this data, first for insights, and then second for activation, where especially in activation, you can see it's a little bit trickier. And what we're trying to do today is hopefully make this a little bit easier for you. If you go to the next slide. So where do we start? It's not easy, but where do we start? And I think 3 valuable questions can be asked. First, to know your customer, which I think, which customer is loyal? How do I define loyal? What kind of data points do you have about loyal? You have a group of customers that have interacted with you, but probably hasn't bought yet, right? So you want to push them down the funnel and make sure they convert. And also, there's a group of customers that haven't heard about you, but who is likely to consider to go in there? So kind of what we're trying to say is you have different group of customers with different data points, and we can use our tools and those insights to kind of drive them to the next step. But knowing your customer is the first step of doing anything around lifetime value. You go to the next slide. So if you think about those 3 buckets, or maybe you want to ask yourself a little bit of a different question, then the question is if I know my bucket, right, I want to know my loyal customer, or I want to know who's going to consider me. What kind of information or data points do I collect that matter to define this group? If you think about a loyal customer, a good metric might be, do they have a loyalty card? Or do they come every week to my website? Or how often do they visit my store? When I think about consideration, you probably think a little bit more about brand lift studies and data points around that panel. We go to the next slide. So kind of what we're saying is first-party data has a lot of different data points, but in the end, it's the data that you own to understand your customer. Why is it so powerful? Is if you collect the data of your customer and you do it well, it's a privacy-first measurement. So if someone buys something in your store, it doesn't rely on cookies, for example. So it's very privacy safe if you did it in the right way. So that's very powerful as first-party data instead of relying on another party to take care of that. Second of all, if you think about first-party data, it's so much data, it's more than just your website, meaning a lot of extra data points, for example, offline interactions or transactions, can improve the modelings already in place. Think about attribution. You make an attribution model only on your e-commerce sales, it's a different attribution model than if you do it on your e-commerce plus your offline interactions, meaning you make your models better. And last but not least, if we can create better insights, we've done it in a privacy-safe way, in our CRM system and in the data that we have in first party, we know a little bit more. To give you an example, probably to the customer, you share what the price of the product is. But do you share what the margins are? Do you share what the profit is? Do you share how often they buy the exact same product? So there's a lot of information in first-party data that we can use to steer our systems. Think about bidding, think about targeting. So to summarize there, first-party data is a lot of data, and it's privacy safe. It makes the current stuff you're doing better, and you can act upon it, which is amazingly powerful. But I think now it's time to dive a little bit deeper on, all right, how do we do this? So Wojciech, take it away.
All right, thank you very much, Vincent. It was very helpful to know all the good examples of how the first-party data can be useful for improving the marketing strategy. So now let's dive more into the customer lifetime value. We'll see how we can easily calculate the values, how we can use it in marketing mix, as well as some useful tips around the tooling about what we can do with the data. So to start with, I think there's no better way of doing that rather than bringing the great quote from Mr. Peter Fader from Wharton Business School of University of Pennsylvania, who is one of the most influential person in the marketing field. So he said that there's no such thing as average customer, right? And the key thing here is to understand that instead of focusing on the artificially built average profiles or some personas that don't really exist, your business might be much better off if you focus on the right people who are the most valuable customers to your brand. And naturally, this links us to the topic of lifetime value. So we'll see how we can actually find out who those people are. So I'm pretty sure that you've heard about the Pareto principle. This is the very commonly known concept of the fact that roughly 20% of your most valuable customers, they can generate up to 80% of the revenue. And this just illustrates very well the point that Mr. Fader was doing. And if we look more in detail for some sectors, for example, e-commerce, this number might vary a bit. It could be seen as 20% is generating up to 70% of revenue. If you look at this curve on the slide, you can see that the model is not linear at all. And for example, just 1% of your clients might be actually bringing up 20% of the revenue, which is really great. Now, you definitely would like to over-invest your marketing effort or any other strategy like cross-selling or upselling your product mix just on the top clients, and maybe under-invest on those who are not really bringing any value to your business. So there are two sides of the picture. And actually, having said all of that, lifetime value analysis actually help you finding out who are those most or least valuable customers. So the idea is to be able to calculate, not only rely on your gut feeling. So also one important thing to realize is that lifetime value is not a new thing at all. Actually, think about your local coffee place that you've been going pretty much all life, and they normally give you a paper coupon with multiple coffees that you can continue buying. You cross them off, and then once after you purchase 10 or something, you get one for free. This is the very well-established way of bringing loyal clients to your business. And other examples might be payback cards. So you keep on buying using one card provider, you get some points back. Effectively, you get very loyal to the brand. And any subscription business, for example, Amazon Prime or National Geographic subscriptions, this is also another way of making sure that you are in a control of who your loyal customers are. You can keep track on them, take care after them, or do any other additional campaigns. So it's not new. Now we'll look at some examples how we can put it in practice. So the very simple example of how to calculate lifetime value might be this situation. Imagine you have two customers, and during the last year, the customer A actually has bought once with the average order of £100, whereas the customer B actually has done 4 smaller purchases with average order value of £50. Now, the question is, which one is more valuable to your business? And I'm pretty sure that you can do some simple math in your head, or you can follow your intuition, and you will see that actually the customer B seems to be more valuable, specifically long-term, right? If you calculate the sum of all the smaller purchases, you will see that it's really bringing more value to your business. Now, so what's the problem? The traditional media optimization might actually more focus on the customer A, just because of the fact that the latest purchase might be higher than the other. So £100 seems more than 50, and there's such a thing called recency bias, and this is one of the things that we need to consider while looking at the long-term picture. The reason is most of the bidding system, they don't really have the data in place. So all the history about repeated purchases, for example, or information about margins or profits that the customer are making on the different products, all of this information is sitting normally on your first-party systems, whereas the bidding engines are not aware of them. So they cannot make the very accurate predictions of what would be the best bet in this case. Also, there are other factors like imagine you have a trial period, so maybe the purchase that you can report to your system is actually not bringing any money at all to your business because it was just a free purchase, or any subscription things. All of those can actually influence very much the bidding methodology.
And Wojciech, if I follow your example correctly, is you show a very easy example of 2 customers, which is very intuitive. But it's so intuitive that it doesn't matter if it's 2 customers, 10 customers, 100,000 customers, or millions of customers, because the recency bias is just at play, if I follow you correctly.
Yeah, great point. It will actually apply to much wider audiences as well. So actually, we briefly touched on the benefits of lifetime value, why it's important. I spoke mostly about the growth. So effectively, focusing on the long term will be more valuable because we'll bring clients who are essentially buying more and more often. But there are also other benefits of focusing on lifetime value. So imagine as marketers, generally we want to justify the budgets that we are spending. We want to know precisely what's the revenue or profit that all of those marketing dollars are actually making onto your business. So being able to report on the true revenue, true profit, will be very helpful to potentially unlock more marketing dollars and improve the overall planning. And the same applies for attribution. So imagine you have multiple platforms or multiple channels that you are working on, and being able to attribute better on which platforms are actually bringing more valuable customers, it's very, very important, because then you can improve your forecasting, and for the future you can focus on the most profitable platforms. So one important thing to realize is that all the clients, they follow the journey. It's not just one-off purchase that we want to focus on. So the journey might be months or years, but we need to be aware that on different stages of the journey, there will be different data signals that we can use. There will be some habits or some patterns that we can analyze as well. For example, the time between different purchases. But it's not just one single snapshot of who your customers are. We need to be analyzing the behavior long term and be able to detect some useful patterns. So if we just zoom in a bit and look at the typical the typical customer journey, we should be able to identify different stages of it, which normally align very well with the marketing goals. So to start with, we have the acquisition phase, which in practice, most of the in-product predictive capabilities live there, which mean that, for example, we can use signals like search patterns or in-app like app installs, or any very early data that can effectively say that the lead is valuable and the lead will convert into the client. This phase will then follow into the development phase, which is yet it's the early time of the customer interaction, but will give us a chance to know more about our clients. So we'll be looking at the purchase propensity, for example, or the product recommendations. Some initial transactions will be in place, so we'll be able to start modeling some of them. And finally, the retention phase, which is very important because we now are collecting much more data over a longer period of time. So the predictive lifetime value or churn predictions are very much well suited in this phase. And the key thing is to be able to understand what has been the journey in the past and how we can model this, extrapolate some data for the future.
Yeah, and Wojciech, if I see your particular slide there, is the three different color buckets that you show here is actually the same color buckets in the initial question. You know your customer, and know your customer could be the blue one, meaning the retention phase or the loyalty phase. We also have the consideration part, which is the beginning of the journey. And in the middle, you want to divide, is someone buying? Yes or no? So kind of this timeline ties back to the same question. Do you know your customer? And what signals do we use to know the customer to kind of map out this particular line?
Yeah, exactly. This is very good reference. Effectively, we want to use the data that are available at different stages. So knowing what methodology we can apply to this, it's key, because it doesn't really help to apply the predictive lifetime value approach or methodology when the client hasn't yet left any good signals. So the approach is important, and knowing different stages of the journey is key as well. Which brings me now to the point that I would like to introduce the concept of descriptive versus predictive modeling. As I just mentioned before, you need to first understand the past in order to be able to predict the future in a simple terms. So as the name suggests, the descriptive models are very much effectively looking into the past transactions, and it's very helpful to understand the behavior. And you can think about for example, user segmentation. You can use them for reporting, or even apply some basic RFM methodology, which stands for recency, frequency, and monitoring. The descriptive models are also the input for any predictive models. So as I said, you need to first collect all the data and then apply some smart elements to it to be able to predict the future. So I can also mention quickly that there are essentially two types of predictive modeling. One is based on the probabilistic models, which are very well parameterized, and they are suitable for some types of businesses, and they are very efficient, very easy to calculate, but not as generic as the second type, which is the machine learning based, which we'll use later on during this demo. And they are great because they can take into account many different signals, and they are suited for a very wide range of different businesses. So now, as I mentioned, machine learning-based models, it's good to realize that there are multiple signals that we can use for modeling. And generally speaking, there are touch points that users either leave during the online journey. So think about the session starts, the time of the day they're interacting with your business, time on site spent on different pages, or number of pages visited. All of that information can come from your Google Analytics account, but also you can enrich the data with the first-party data that you track on your CRM system. So think about user demographics, information about the profession, or the lifestyle information, or any type of financial data. For example, the loyalty cards, payback points, or referral schemes. By doing this matching, you can actually get the full picture of your customers, and then you can use the magic of machine learning to decide which signal is actually more correlated with the fact that the client will be mostly loyal to your business and will be buying more in the future. So finally, I wanted to touch on the tooling. There are some open source projects that our customer engineering teams at Google have developed to help the clients essentially accelerate the process of data onboarding. So they are meant to be useful when building workflows, or bringing machine learning models into production. Please contact your account manager if you would like to learn more about them. You can also find them on GitHub. They are fully open source and just ready to go whenever you need them. Right. And with this, I would like to pass over to Vincent.
So we learned in the beginning about the importance of first-party data, and then Wojciech was so nice to explain us a little bit what kind of identifiers do we have, what's the difference between descriptive and predictive, which is a good starting point to know like what's out there and why do we need to do it. but what kind of questions do you ask yourself? And I think with first-party data, we can actually ask very complex questions. So what we'll do now is I'll drop some statistical terms so you know a little bit what kind of models are we thinking about. And second of all, if you're not a statistician, you as a marketeer should know data scientists and statisticians are able to do this, but what do I do after this as a marketeer? So if you go to the first model that we think about is a use case is building clusters. Or if you think from a marketing perspective, you're building segments of groups of users that you would like to target, for example. So if you think about that, on how that works, from a statistical model, one that often builds clusters is something called k-means clustering. And to try to explain it in very simple terms is we kind of want to group different customers together in k amount of clusters. So in this example, you can see 6 of those. And kind of what you do is you use different signal points, like dimension 1 and dimension 2, to kind of plot everyone on there and then see, all right, what kind of clusters can I find? The model gets better if the clusters are completely separate. The model is a little bit worse if you can see the circles overlap a little bit more. So our example here is a very, very pretty model on that. But what you need to remember is here we use 2 dimensions. It could be the amount of conversions on the x-axis and time spent on site on the other axis. Meaning we use 2 dimensions to put people in different groups where we say, all right, if you have a lot of conversions, but you don't spend a lot of time on our site, then probably want to bring you back to spend more time because you're likely to buy something. But k-means clustering is more advanced than that, or modeling can be way more advanced than that. We cannot use 1 dimension or 2 dimensions. We can use infinity amount of dimensions. We can use hundreds or thousands of them. And k-means clustering still gives you a result of calculating the overlap if the model is really good or not. So statisticians really can help you building segments of your users, groups of users, where you as a marketeer, as soon as it sits in the Google Marketing Platform, would like to say, all right, I have 6 groups of users. Let's create 6 different audiences and use these audiences in my search display and other campaigns. So that's one way of thinking about it when a statistician or a data scientist makes a cluster model, and you can use that directly in your audience strategy. And I think that's how the 2 teams can work together. To give you another example, another use case is something we call propensity models, or how likely are you to convert, where we kind of take a different approach. An approach that's often used is something called a logistic regression for the statisticians among us. For the people that are not familiar with it, what it's trying to do is use different dimensions or different input variables. And as an output, we give every single customer in there a score between 0 and 1, where we say 1 is very, very likely to buy, and 0, you're actually not likely to buy at all. Meaning if we have a score of that customer, there's 2 different things that we can do. One thing is the example on the slide. We say, all right, from 0.8 to 1 is 1 bucket, very likely to convert. From 0.5 to 0.8 is medium, and 0 to 0.5 is not likely. We can make these into audiences. If we add these audiences, we can target differently. But we can also just add the audiences and make auto-bidding use those signals to be smarter about this. So again, the audience use case, like k-means clustering, is still relevant. The second thing that you can consider is we have a score between 0 and 1. We can send this score also to our systems as conversion tracking and say, if someone's really likely to buy, we have a very high conversion. While it's not likely to buy, we do a very low conversion. And especially if you think about upper funnel marketing, which is really difficult to have a conversion when someone has seen an ad, this might be a very good way to kind of optimize your bidding system to help show more ads to the people that are likely to buy versus the people that are not likely to buy. So again, the thing from the statistician here is the statistician can make the model to give you the score between 0 and 1, while the marketeer can say, all right, I can either make audiences out of this, we have an example of 3 on the screen, or we can use it for conversion tracking, which is a trickier thing to solve, but just I want you to know that the data pipeline can be built. If we go to the next slide. So to make this a little bit more alive, what have we seen in the industry? And one example I really like is from the finance industry, where they actually said, all right, we have a lot of customers taking a loan from us, but there's a difference between someone taking a loan with a lot of monetary value in it versus someone with a loan with a lower monetary value. Meaning that someone who has a higher loan is probably more relevant for this business than someone out there. Meaning if we can use that data, which is probably in our CRM system, we can input those people into audiences and really start optimizing towards this. And one additional note that they gave is people that have a mortgage, which is a relatively big bracket of a loan they have, are also likely for home insurance. So next to using this as a principle for targeting and making sure you get the most valuable customers and you spend more on them, second of all, they create an opportunity for cross-sell, which I think is a perfect example of how you can use the lifetime value calculation, Or simply, we have a value from 0 to infinity and put people in brackets and use that in our marketing activities. To give you another example, from the online grocery industry or from the supermarkets, is one thing they notice is that they have different clients on their website, but there's one particular type of client who buys a particular subset of products, in this case, fresh groceries. And what they know from these people is they come back very often because fresh groceries go over date. They probably make fresh meals. But it does mean that if someone gives you the data point, I buy fresh groceries online, you're very likely to return, and you probably do more online instead of offline. Meaning your online marketing is way more relevant for these people than for the other people. Meaning you can use a lifetime value model to predict, all right, how likely is someone to buy a fresh product? Because if I know that, then probably I want to target them with my online marketing campaign. So I think this is a very powerful example from the supermarket, a completely different industry, where lifetime value is very relevant in both of them. Where we use the techniques that we discussed, right, the logistic regression or the propensity to buy model on one end, but also maybe the k-means clustering, which is more like the supermarket element in this one. Back to you, Roger.
Right, thank you very much, Vincent. So great examples. Now let's actually talk about one of the practical example of what Vincent was just explaining. And for this reason, we're going to use the logistic regression, and we're going to build the predictive capability, which is the propensity modeling, using some of the available tools in the Google Cloud Platform. And if you have never really heard about BigQuery, no problem at all. I will introduce it briefly, and we'll also introduce some of the very basic machine learning concepts. Right, so let's jump straight to it. So in the next couple of minutes, I'd like to show you how you can build a propensity model with which will forecast what's the probability of each of the new visitors to your e-commerce to finalize the purchase later. And to keep things real, I would like to introduce you to the Google Merchandise Store, which is the real e-commerce portal where you actually can go and buy some of the Google branded swag or colorful t-shirts if you like. What makes things easier for people to start playing with Google Analytics data is the publicly available data set, which has been recorded throughout the year in the past, 2017 and 18. And thanks to that, you can get the raw data recorded on the real website, and you can use it for any type of experiments or testing. And hopefully you can make this work during this demo. So naturally, the modeling is just one phase of the end-to-end process that might involve other phases like collecting and transforming the data. And then obviously after the model has been built, you would like to activate the results, make them available in the media buying platforms. So luckily for us, we have the first phase, collect and transform, already done. We can access the data in BigQuery, and we won't be focusing today about the activation piece, but the modeling can be actually very well done using the cloud tools. And just one important thing to stress out, as in any machine learning based project, all of those stages are essentially iterative. So they need multiple iterations, similar to the agile development, to make them work. So you need to learn along the journey and then improve the model, and then finally keep on activating those results, doing experiments, measuring your results, and then starting again. This is the reality, and it's very well tied to the agile development in general. So as I mentioned BigQuery a couple of times, let me just quickly describe what it is and how it can be helpful. So in a nutshell, BigQuery is an enterprise data warehouse, which provides a very simple interface you can access to process petabyte scale data in a very efficient way. So for example, if you would like to process the entire data set of Wikipedia records to find some stats about your favorite topic, for example, you can literally get this insight in a matter of seconds. Also, BigQuery provides some unique capabilities like machine learning modeling in the form of BigQuery ML, which for everyone who is familiar with basic SQL, it gives a chance to start experimenting with BigQuery on the larger sets, as we'll see in the example in a couple of minutes. So it's a very much democratized way of using machine learning for
And
any data analysts.
from a practical point of view, what you get right that the SQL language is most dominant in BigQuery. So if you know a little bit about SQL, it's already quite easy to get started.
Yes, absolutely. It's very, very nice learning curve, and you'll see in a few minutes that it's effectively just mostly using your current knowledge and adding some extra bits to it. So to introduce the BigQuery console, we'll see it in a few minutes. But the only thing you need to know is that BigQuery is web-based and can be really easily accessed by the Cloud Console. You could also use the API, but for our purposes, we will just focus on the UI. On the left-hand side, you can see data sets and tables, and the main section you will see that SQL commands to query data and to process them to build a model, for example. And then the results will be presented in the bottom section. And you can also analyze the results in Data Studio to understand how your data looks like or what's the shape of your data. And obviously, you can export your results into multiple formats, including sheets or CSV files or even other BigQuery tables. So now let's actually take a look on the data itself. As I mentioned before, we're going to analyze the visit metrics from Google Analytics. But in order to make them ready for machine learning purposes, we need to aggregate all the raw data at the user and session level, which means that we'll understand how the users behave during the session, specifically the first session, the first interaction with the tool. So in machine learning, we talk about instances or observations. And in this example, each row represents an observation, which will be then used for training process. And we obviously need to predict something. So we use a column called label, which will be the one that we will be trying to predict. And in our case, the flag, the label represents the binary flag, which will indicate whether the user has converted or not. And for that reason, we'll be using logistic regression. But if you wanted to predict a numeric value, for example, lifetime value, the dollar value of the user, then the model might be different. For example, linear regression might be used instead. So another thing to consider is that in machine learning, in general, we use a process called training. And to be able to train data, we need to provide a training data set, which will comprise of the features, which are representing the user behavior, as well as the labels. So we already know how the users in the past have behaved, and we can input this information to the machine learning model to model the relationship between the features and the label. And this is key to make the system actually work and work out what's the relationship between those things. And after the model has been built, obviously we have a new data available in the system, which represents the new users in the site, which we are really unsure of whether they will convert or not. And this is the test data set we will be using to assess the value, right? So as we just described those things, in practical sense, also we can expect the model to find some numerical weights which are attached to each feature to then know which of them is more significant for the predictive capability. So imagine some features might be less significant, or in other words, less correlated with the output. We don't have to worry about that because the machine learning will figure out what is the magic formula behind the data itself. Okay, so with this, we've touched on some practical terms. Now, let me very quickly switch to the BigQuery console so we can see how this data can be actually analyzed. So first thing, I'm on the BigQuery console right now. I can see that there is a a raw data set on the left-hand side, which represents the historical data from Google Merchandise Store. This will give us some of the idea of how the raw data looks like. But I have prepared the query which will effectively aggregate all of the raw data signals and will be then ready to use for the machine learning process. I'm running the query right now. It should finish off in a couple of seconds. This query, the only thing we need to understand is that it's aggregating the user behavior on the site, and then we'll present the table similar to the one that we've seen on the slide. So this is the situation where we have the data. We will see that there's a label which represents whether the user has bought or not. The only thing we need to do right now is to enable the modeling part of this, and those three lines represent creating a model. We need to choose the model type and the label that we want to predict, and that's it. That's the only change we need to add to the SQL that we already have built in order to build the model. Then we'll be ready to create predictions for the future.
Wojciech, if I follow you correctly, the first query that you've run is kind of a more technical way with SQL, like you usually do with a spreadsheet, right? You're just preparing this particular spreadsheet. Yes. And now you've added a few lines of code where you say, right, they have this data spreadsheet, and the extra lines are the model to give you the prediction afterwards.
Yes, that's exactly correct. So so far, the only new thing that we might introduce is just those three lines in here to create the model. Now, the model itself might run for a couple of minutes, not longer than that. But luckily, I have already prepared model, which I ran before. So now, whenever you have the model, you are able to, again, select the data that you are interested in, which is effectively the new users to your site, in the very similar, in the very similar way that you had in the first query that we've seen. This will be the input for the model to run the predictions. And you will see that there is no label in here, so we don't know whether they have converted or not. By adding the predict command in here, choosing the right model that we've seen before, if you run this command, then you will be using all the features available, and the model will determine what's the probability of the user to convert. So you'll see, for example, the label, which is 1 in here, will have this probability of conversion, whereas the Z will be the other one. So this user probably will not convert on your website. And
yeah, maybe to explain that, so each row or each full visitor ID is like a user.
Yeah.
And then we either know from them as an input they bought something or not. And then the probability next to it is just a score or a percentage between 0 and 1. How likely is it to score? So if you think about a percentage, and let's say theoretically it's 0.5, it's like someone is in the store, has the product in their hand. They do a coin flip with a fair coin. If it lands on heads, they're going to buy it. If it lands on tails, they're not going to buy it. So that's the way to interpret it. That's the probability number.
Yes, that's exactly correct. And the last step you might actually want to do is to run another query without any modeling elements of it. The query will give you a match key, the one that you can use then to activate those results in Google Analytics, for example. And the probability of user to convert will be extracted from the other data set. So this is just for your convenience to be able to have one single file, which will have the match key, which is effectively in this case the user ID or the client ID in Google Analytics, and the probability. Then you can then either create the audience, or you can use it as another input for the calculating lifetime value. So you can multiply it by the revenue value, for example. And from here, you can just use it in the activation phase in the system that you prefer. And that's it from my side.
Cool. Then I think we had a few questions that were submitted beforehand. While we're also busy to answer some questions in the live chat at the moment by some of our colleagues. So maybe we can pick a few questions at the time we have left.
Right. Yeah. Let's do
So
it.
really,
So the first question from our users is how we can activate the lifetime value results into Google Marketing Platform.
yeah, let me take that one. So I think the story of WatchCheck ended with we have a match key, which is very important in this one, and we have the outcome, which means that that's something we want in there. And I think there's 4 solutions that I see the most in industry to use that match key, which is different per platform, and then upload this probability in there. So if you think about Google Analytics' first tool, you have data import, where you can use, for example, the client ID or a product ID, etc., to use that as a match key and then upload this probability. The second way Google Analytics can use it is measurement protocol. So that there will be an alternative to data import, has some benefits and non-benefits. But again, data import needs a measurement protocol needs a match key, and you can send the score as well. If you then think about SA360 and Campaign Manager, then one that I often see being used is the offline conversion API. And in the offline conversion API, you can, for example, use the click ID or device ID or anything along those lines to upload something for either your Search Ads 360 or for Campaign Manager, which you can thereafter use in DV360. Last but not least, in Google Ads, we have also the offline conversion import, which you can automate via the API. And there very often the click ID is used as well. So to answer your question, it's very important to know which match ID you have. We don't really care about the score because we can upload it. And think about in which channel do you want to use it. Do you want to use it directly in search, or do you want to first send it to GA to use it everywhere? So I think that's the question you need to ask. For every Google product has a solution, but it really depends on if you get the right match key. And with Google data, like the export from analytics, an example, it might be relatively easy. But when we talk about CRM data, some additional questions might be raised. Cool. And the second question, how can we get first-party data into BigQuery? So you showed the example of GA WatchCheck, I think. I think people are interested to see, is there more possible?
Sure. So yeah, this is a very good question. As we've seen, there are already very well established ways to move the Google Analytics data to BigQuery if you're using the Google Analytics 360 capability. But this is not the only way. In BigQuery on its own, there are multiple connectors which are part of the BigQuery data transfer service, and you can think about multiple CRM systems like SafeStore, or you can use some other connectors which are effectively using CSV files or Google Cloud Storage buckets, for example. Anything that is sitting in your kind of first-party systems, whenever you bring the data to the cloud, there will be an easy way to integrate it with BigQuery. And the bottom line as well is that you could use multiple cloud providers as well. It doesn't have to be Google Cloud Platform, but as long as you are making the first move to move the data into cloud, the rest should be fairly simple to kind of ingest that data into BigQuery itself.
Nice.
Yeah, very good question. And finally, another question is, I'm not very familiar with cloud and programming in general. Is there anything I can do to use lifetime value today?
I think a very fair question to ask, where I think you saw a little bit of coding, you talked a little bit about statistics. I understand it can be a little bit scary, but actually Google does do some of the heavy lifting in that one, if I'm really honest. But I think the first question you need to ask yourself is this more a descriptive use case that I'm having, or am I trying to predict something? I think that's the question, even if you don't know coding, you can ask yourself is, do I want to know a little bit better reporting, or do I actually want to activate something? And if you think about that, for both tools, Google has some solutions where they do the programming and the statistics for you. So if you think about descriptive, there is one tab in Google Analytics called the lifetime value calculation, where they kind of make a calculation for you, all right, based on all the e-commerce transactions or all transactions in GA, what's the lifetime value of this customer? So they do a little bit of the modeling and just give you the output. If you think more about predictive calculations, then I think 2 dimensions in analytics might be really relevant, which is session quality or conversion probability, which are kind of doing the exact same calculation that WatchCheck was showing you. It's saying, all right, between 0 and 100, I give you a score, how likely is someone to convert either within a session or within a user level, right? The user with multiple sessions. And then you can use that score from 0 to 100 to make audiences out of it, for example. So in other words, what I'm saying is we have the lifetime value reports, we have session quality, conversion probability, and more things coming. But actually, where we do most of the calculations, as a marketer, you can just make use of that. So can you use lifetime value today? My answer would be yes. Google can do some of the calculations for you.
Awesome. Great question.
Cool. I think we're running out of time. So I'd like to thank everyone for their time and listening into the session. If you found this really interesting and you would like to learn more, I would highly recommend to subscribe to see more of the live sessions, and maybe check out the website as well, where you can see all the previous sessions. It might be some of the interest. But thank you very much for listening, and I hope it was very useful for you to get your hands dirty on lifetime value.
Yeah, thank you very much from my side. Please stay safe, and I will see you in the future.
Thank you.
Bye-bye.